Hello everyone. In this exercise of the SolidWorks, we will understand how the simulation in the SolidWorks works. So in this we will see the simulation in the rectangular steel pipe. Let's start. This is the SolidWorks user interface. This is the color. I am selecting the background. Unit system is this one. Firstly, we have to see in the tab below the command manager, there is a simulation tab available or not. So there I right click to apps. So there is no simulation tab here. In order to bring the simulation tab, you go in the above section add-ins, and here you can click the SolidWorks simulation and OK. This one. This is the SolidWorks simulation will appear here. Simulation appears here. So in the simulation, first we have to create the steel model structure. So then I take a front plane and make a, firstly we have to prepare the model in the simulation. So I am taking this line simply, and this length is I am taking this length is 700 mm. Okay, this is I'm taking 700. Now out of the sketch, in the weldment section, I am taking the weldment and steel structure rectangle. I am taking ISO standard rectangular pipe. That is the size I am taking 120 into 88 mm thickness. Group, only one group is there. I am taking one is only the single pipe on which we will study the simulation. In simulation, actually we will study, we apply the forces and we see the behavior of the material, how the material behaves in the terms of the stresses, in the terms of the displacement, in terms of the strains and yield and the stresses. So let's start here. I'm hide the sketch. And firstly, I define the certain areas in this pipe for the application of the force and fixed geometry. Two areas I have to establish. I am selecting this face, sketch, and selecting the right center, this one, and this is this one. This one, I am taking this dimension. I am taking 40 mm only. Okay, this I am taking 40 mm and taking this line and this one, and this I am taking horizontal. Sketch is not fully defined. I am taking dimension from here to here, that is equal to dimension I am taking 700 divided by 2. This one. Sketch is fully defined. Now out of the sketch, future, and here split line. Projection, here type of the split is projection, and sketch is already selected. This one, surface is this one. I'm defining the area. I am defining the area for application of the pressure and the fixed geometry. One area I have demarcated. This one is the force. And now select this surface and sketch, and select this corner rectangle. This one, same. This I am taking 30 mm. And this I am taking 30 mm. Sketch is fully defined. In the same fashion, out of the sketch and the future, and here is the split line. I am selecting projection. Sketch is automatic selecting this one. Select this surface. So we have located two areas for the application of this one in this one. For the application of pressure and the fixed geometry. In the simulation, first we will prepare the model, and this model I have created in the weldment section, and the next is in the simulation tab. Simulation tab, go in the new study. We will study the static simulation only. In the static simulation, we can give the name static, any name of you can give static rectangular pipe. Rectangular pipe. I have given the name static. Okay, and there are different studies also. We will see in the later exercises and this one. Okay, now there are new window appears. New window appears here. Firstly, we can apply the command manager, or we can operate from this section also. Suppose I apply the material, click here, and you apply the any material. You can, as per I am taking ISI 304, apply tensile is this one, Newton meter square, apply and close. Material I have applied here. If you will see here the material, if you see there is green check mark, it means material we have applied here. Okay, next is the connection. There is no connection because this is used in the case of assembly, but we have the one part only, so there is no need of the connection. Fixture. Firstly, in the static study, we apply the fixed geometry so that the body could be maintained in a stable condition. This is for that purpose. Static means areas are fixed so that body could not move. Right click, fix geometry. This one, fixed geometry. I am applying the fixed geometry's area. This one. That's why I have created these two split lines here. Okay. First we have for the application now external load. Apply external force. I am applying the force. This one, normal selected direction. I am selecting this face only. I will apply the force only this section only. Selected direction. For the selected direction, you can take the direction in which particular direction you do. I am selecting this one. The force is vertically downward. SI unit, I am taking unit SI, and the force I am applying Newton. I am taking the 1000 Newton. Okay, this is this one. You can reverse the direction from here, this one, but I am taking downward direction. Okay, this one. So I have applied the force, and now is the mesh. Right click and create the mesh. This is the mesh. In the mesh parameter, this is the mesh. For the mesh parameter, this is the size of the element, and this is the tolerance between the elements. This is the default. I am taking the standard mesh only. If you move this density to the finer side, it means we will get more accuracy with the more accuracy side. But our CPU consumption will be more, and will take calculation will take more time. So that I am taking in the middle and the standard mesh I am taking. This is the tolerance. This is the element of size of the element. Okay, I am clicking OK. Hit the right button. Okay. Now the whole part is distributed uniformly into the small. This is finite elements. Okay, as per given sizes. This is the mesh. Now we have to run the study. Run this study from our command manager. There is a run this study. You can run this study. This is calculating. This is the you will see this is the stress value. This is the stress value. This is in Newton per meter square value. Okay, but this is showing deformation scale is 4131 for 135.12. That is a very large scale. So firstly, we have to define the true scale. So for that, this is the stress value. Stress is generated. Stress is generated. Right click and the chart option. In the chart option, go in the definition section. You can you change the unit. I want to change the unit in the Newton per millimeter square. 1 Newton per millimeter square is equal to 1 megapascal. Okay, I am taking this one, Newton per millimeter square, and this way, and the definition true scale. True scale means in the one scale, or if you want to change the scale, user defined, customer in what fashion he wants or what scale he want to see the stresses, you can allocate this one, assign from them. But I am saying actual true scale. This one unit I have changed, and this one, this unit changed. So yield strength is that strength. Okay, this is the stress. So you see the stress value. This is the maximum and this is the minimum. If you want to show the minimum maximum stress, you can go in the chart option, and chart option show the minimum maximum annotation and the minimum annotation, and this is okay. You can see there is the maximum is 8.083 into E raised to the power 0. E means 10 raised to the power 0. Okay, this is the meaning of E raised to the power. So you 1.13 minimum E raised to the power minus E means into 10 raised to the power minus 0.2, and E raised to the power minus 0.2 power. This is the E stands for 10 raised to the power. Okay, so yield strength is 2.02. So, but a maximum stress is less than the yield strength. What is the yield strength? Yield strength is the that value which a component can bear safely without deformation. That is the yield strength. Yield strength of any part, structural steel structure, it is that strength which component can bear without failure. This is the yield strength. Okay, this is the stress value here, or maximum minimum stress you can find out from here on the true scale. In the same way, displacement, if you double click here, double click in this way, so this is very much too much deformed scale, but this deformation scale is 4132. But I am taking right click, chart option, or definition. This is the true scale, this one, and okay. Now this is the actual scale. Actual scale, you are seeing the very much deformation. This is the maximum is the, if you want to see this one, this is 1.1 into 10 raised to the power minus 30, and this is the this value. So this value, if you maximum, this is the, if you will see the 1.693 to 10 raised to minus 2, that is 1.6393 divided by 100. That is the very less displacement of this. You can animate this scale, this animation. You can see there is a, you can see from the naked eyes here. You can increase the this one frame from, you can increase from the frame here, the speed you can increase from here, and save as a AVI file. You can want to save the file, this one. If you play it, you can play it. So in this way you can see the same thing. On the unit scale, the deformation is very zero. This is maximum is 1.0693 divided by 100, in that comes in the point. So this is very less deformation which is acceptable. Now strain. What is strain? Right click, double click. If I double click, this is the strain. What is actually strain? Strain is the ratio of a change in length divided by the original length. That is the strain value. So this is not on the, this is on the deformation scale of 4135, but I want to take it on a unit scale. Chart option, that is the, or definition, this is true scale, and if I hit the right button, you will say the strain is very less. This is the strain, 2.065. What is strain? Strain is the ratio of change in the length divided by original length. That is the, after the application of force, there will be, if there the strain occurs, it means change in length, or final length minus original length divided by original, that is known as the strain. You can measure, that's the maximum strain is this one. E means 10 raised to the power. Okay, this 2.065 divided by 10 ratio 5. That value will come in the points, that is very less. Okay, you want to animate, right click, animate, you can animate it. Okay, this one from here. You want to increase the speed, less, you want to decrease the speed, this one, and you want to save the file, you can save here. Okay, this one here. So this is the value we can find out. Or if you want to find the stress on the right click and edit definition, reld stress and probe, right click and probe. There is one section of the this one, weld option, stress, this one, we will probe. You can find out the stress value, this one, show edit definition, this one. This is the this. And now most important thing is the factor of safety. Factor of safety means for the factor of safety, you go in the command manager, there is a rel advisor. Here is the new plot, and this is the factor of safety. This one. That all selected of bodies means if there is a assembly of the parts, it means that in that case you select this selected bodies. Automatic, this multiplication factor 1, factor of safety distribution, this one. Is factor of safety is 26. It means factor of safety is there should be minimum 1. Okay, is this factor of safety means 26 into applied load. It means factor of safety, if the factor of safety is 26 means it is very safe, and it means 26 into applied force is 10,000 Newton. It means 26 into 10,000 Newton force it can bear without the failure. This is the mean of factor of safety. In this way you can find the factor of safety, strain, displacement, and later on we will do the exercise in the assembly section also. So actually in the simulation we study the behavior of the material as far as stress and displacement, strain and factor of safety is concerned after the application of force in the static simulation. Static simulation means we fixed the some part of the body so that it could not move, and then we apply the force in this way. So I hope you would have enjoyed this exercise. You please like, share and subscribe my this channel. Thank you very much.